computer. And let me repeat what I just said. I said this coming Tuesday, we will not have a class because I'm going to be out of the state. And today I'm going to go explain to you the project. And I'm going to give you a little bit of help on how do you answer the question of the project. The assignment and the project are both available. Due dates are 28th of November, I believe. And of course, if you guys have any questions at any time, make sure you send me a Canvas email. I will make sure to get all the grades up to date by the end of the Thanksgiving weekend. Okay, so with that being said, let's go straight to, where is it? I don't have it opened. One sec. So I'm going to try to share my screen. Now, there was one piece left from last week that I didn't talk about. It's a very, very short part, which is using the keyword final in a method inside the superclass. Now, if you remember, last class, we created those 4 classes. We created a person, student, course, and structure. And we said students and instructors are going to be simply inheriting from person, and the student will have an array list of courses that the student is enrolled in, and the instructor also has an array list of courses that he teach. So we created those two they call them classes, and they're both subclasses that are inherited from a superclass. And then we have the course class itself, where we have some primitive data types. We have static member for the number of courses created, and then we have the credits for the course and the course name. Now, today I want to show you here, and this is just a demo, just to show you what is the meaning of having a method with the final keyword. The final keyword simply means if you have a method inside your superclass and you don't want that method to be override by any of the subclasses, then you just go ahead and use the final keyword. So to demonstrate that, if I come here and just type the word final, and now if I go back here to this class, immediately you see I have an error here. And if I go to the structure class, I will have an error here. And as you guys remember here, we said we're going to override the final, the print method, because in addition to printing the data members of the person class, we also need to get the student ID and the courses to be printed as well. So we called the print method from the superclass by typing super.print. But again, the idea here is that just because I put the keyword final here simply means this method, you cannot override it anymore. Now, again, this is optional, of course, and it's up to you to decide whenever you want to use it. And to be honest, I cannot think about a case where I would like to have a method to be final. Maybe you can search and see if you can get an example, a good example of when using the keyword final will be a good idea in a method. So that's one of the parts that was left that we didn't talk about last class. And the other part, which is, again, not anything special, but let me just go and here, one sec. Command N. Okay. And I'm going to go to, let me share my screen. I'm going to stop sharing this. And let me move and share my Word document. Now, I talked about how do inheritance work with UMLs. And to demonstrate that, I'm going to show you a very, very simple class. Now, imagine this is a UML of a class. This is where you type the class name. This is where you put your data types. And this is where you put your members. And this is, again, another class And this here is simply your class name, and here's your data types, and this is where you type your your public methods. So if I, for example, let me just go back to the row. Imagine this here is the student. I need to buy a tablet where I can draw. This is a student and this is a person. Okay, since the student is inheriting from the person, so we usually do that in a way where you draw an arrow to the class you inherit from. I hope I'm not making a mistake by that. Let me just go 1 sec. I know that that should be the case. 1 sec. Yeah, you should have that in the PowerPoint. I don't know if it was mentioned or not. Let me try to see. Oh, this is a rate list. No. 1 sec, please. What chapter is this? Chapter 13, right? Yes. So let me just make it available. And here we go. I'm pretty sure you guys. Yep, I got it right. So let me just go back to the Word document. So this is again, the only reason why I had to come here, I just want to show you that whenever you want to do a presentation for multiple classes, when you have a class that inherit from another class, you simply draw both UMLs for both classes, and from the subclass, you draw an arrow to the superclass, and that implies that the student here is inheriting from the person class. So those are the two topics that were left from last class. And now I am going to go through the assignment and the exercise for this week. And I'm going to go and show you what are the requirements. And I'm going to give you a little bit of help with the project. So let me share my screen. Let me get here. You do have project 8 that is due November 28th. And we have homework 9, which is due November 28th. If you click on homework, you will get this file. Now, in this file, in the book that we're using, chapter 9, those are the pages. You have to answer question number 1, 3, 5, and 6, and 8. Even though they look like there are 5 questions, but believe me, especially the first 2, the answer for these 2 questions is a single word, or maybe a little bit more. 8 is simply when you're going to have to write a program, I believe. 6 and no, 5 doesn't have to write a program. 6, you'll be given one of them. You'll be given a program. You're going to be asked about the output of it. So probably just those 2 where you have to write a program, and it's very, very simple and very, very short. So this is not a very, very big deal. The big deal, if you will, it's the project 8, and let me open it. And even though it looks very, very short, the challenging part is going to be at the end of this project. So what am I saying here? I want you to create a superclass called building. And the building has attributes, which is an address and number of floors. And I want you to implement a method called display info, which is simply going to display information about that building. And the superclasses present essentials information about the building. Okay. I want you to create 2 subclasses. One of them is called house. The other one is skyscraper. Those 2 classes are going to inherit from the building class. And for each one of those classes, for example, the home class should have attributes such as number of bedrooms and has a backyard. So has a backyard, simply it's a Boolean variable. Could be true, could be false. Now for the skyscraper, we got number of elevators in that building, and number of windows in the skyscraper. So it's very, very simple, very, very straightforward, nothing very special about it. And since you're inheriting from the display info, so make sure that you override it because you're going to have to include the other attributes for the subclasses. Now, here it is. I want you to override the display info. So you're simply going to show me the other characteristics of each one of those type of buildings. Now, in your main method, I want you to create two arrays. One array is a type of house. The other array is a type of skyscraper. And I want you to assign at least 3. You can go more than that. So every single array should have at least 3 houses, and the other one should have at least 3 skyscrapers. Now make sure that the data types, the values of each one of those objects in each array are different. Now,
Question.
yes.
This is all going to be hard coded, right? When we make the arrays and give the information, it's all hard coded.
Yeah. You don't have to go with user input and stuff.
Okay.
Mm-hmm.
Okay.
Now, the difficult part is this part here. I want you to sort the house array based on the number of bedrooms, and I want you to sort the skyscraper based on the number of floors. Okay? Now, there are 2 ways to get the job done. One of them is to do it from scratch. And I'm going to see if I have time today, I'll try to show you that. And the other one is to use the tools that are already available. Okay, so what I'm going to do, I'm going to show you both cases to explain it to you. And then after that, we'll see how things are going to go. Okay, so I'm going to show you both ways, explain to you both ways, and I'll let you decide whatever you want to work with. I'm not going to be picky at this point. Both of them, I'm going to actually post them, and it's up to you to go with whatever you feel like you want to go with. So the submission format, simply, I want you to, after you write your code in whatever IDE that you're using, put the code in this box here, and make sure you copy the results after you run your program and you put it here. I didn't give you any outputs here. My ultimate goal here is to see your array before sorting and after sorting. That's simply what I'm going to be looking for. Now, with that being said, what I'm going to do, I'm going to show you a demo, a very simple one. And this demo is going to be about books. So I'm going to create class about books. In the books, we will have a title and number of pages. And then after that, I'm going to try to sort array of books based on number of pages.
Question.
Yes.
So you want us to use this same file to paste our code?
Yes, the same file.
Oh, okay. It's not a PDF? Okay.
Yes. Okay, so let me just move to Eclipse. And I'm going to start a new project. Okay, I'm going to call it sort objects. I'm sure you guys are not seeing this window, but it's okay. Here it is. Delete this file. And I'm going to create 2 classes. One of them is going to be called book. There is no main method inside the book. And the other class is going to be called main class with a lowercase a. And this one has the main method. But now that I have those, I can come here and close all these old files. And let's just focus here on the book class. Now, as I said, private string title, and then private integer number of pages. Now let's go ahead and create the public book, and let's just create the constructor for it. So we'll have a string title here. And we will have an integer number of pages here. And again, I'm going to make sure, do my best to not make it complicated. So this dot title equal title. And then this dot number of pages equal number of pages. Now let's go ahead and create the setters and the getters. So let's go ahead and do setters and getters. So sources, generate select all. And then after that, let's create the toString method. Okay, generate, and I'm done. So you can see here, I got the whole thing done super, super fast. Okay, what else should we do? Let's go ahead here and create, let's
quick
create,
question,
yes,
Humar.
go ahead.
So we're making as one array for skyscrapers and one array for houses,
Yes,
right?
yes.
And we're sorting each specific one. So we're not sorting skyscrapers and houses together. We're
No,
sorting
no, no.
them
Each one
separately.
of them separately. One of them, you're going to sort them based on number of pages. Sorry, not no, bedrooms, and the other one based on number of windows or elevators. I don't remember, but you choose one of
Okay.
those attributes.
So we're making two array
Yes.
lists then.
Mm-hmm.
Okay.
Okay, so let's go ahead here and have a look at the main method here to create an array of books. So book, and I'll just call it my books equal, and I'm just going to go ahead and immediately do it like this. New book, and I will say the title, I'll just put TTT again. Remember here, it's not real book, so I'm just creating new book. You go ahead and choose whatever title you want to add here. You know, let's just call it book one instead of those TTTs. So book one, and we'll have book two here. And I'll put, for example, here 55. And then finally, new book. And I'll put here book three. And number of pages, I'll put, for example, 100. Now let's make it for new book. And this one's going to be called book four. And I'll put, let's say, 23 pages. So here it is. This is my list of books. Now I could come here and say for book B, and I'll say my books. And this is again me trying to just print them. System dot out dot print line. And inside here we just put B, so we'll be able to see. Now if I just give this a run, oops, what did he doesn't like something here. Oh, he doesn't like the main method. Expecting thread of main error. Why is this going on here? Some reason he doesn't like this. Stored objects. Oh, here it is. That is weird. Well, let's see if this is the case. No. Am I? Oh, book with a lowercase k. Okay, let's see if that's the case. Oh, that's weird. Okay, so he didn't tell me that the error is with this character. He just told me the main method has an issue. Anyway, so you can see here, the books are book 1, 2, 3, 4, but you see the pages here are not sorted. So the question is, how do we sort this array? Now, here's what we can do. And this is going to work perfectly fine if we have primitive data types. So let me just show you what do I mean by that. If I come here and create an integer, and this again, we'll just call it test equal, and I'm going to say, for example, 5, 1, 3, 9, 2, 7. And if I come here and say arrays dot sort, and I'll put test here, semicolon. Now he's complaining about arrays. He's going to tell me you're going to have to import arrays. So I'm going to import it here. Now, if I just try to print it, so for integer x in test, and if I just come here and say system.out.print line, and I'll just say print x, and this is uppercase S, of course. Now forget about this book thing and let's just focus on the sorting algorithm that I have here. Now let me put a space instead of print line. Okay, what are you complaining here? System.print. Oh, wait a minute, plus. Okay, let me run it. So you'll see that the data now is sorted. So you see that's very simple, very easy, fast way to sort an array. Now the question is, can I replace test with my books? Okay, so I'll just put it that way. So instead of sorting primitive data types, I decided let's sort books. Now let's run it and see what's going to happen if that's the case. And let me run it. So this is before and this is going to be after. And let me just have a breaker here. So system.out.print line. And I'm just going to print those dashes. And this is just a breaker so you can see the difference between the before and after. And semicolon, of course, here. Let's give this a try. And here we go. That is exactly what I expected. Now, the reason why sort algorithm is not being able to sort my books, because my books, it's not a primitive data types. So the sort algorithm simply doesn't have any idea about how to deal with object that has been created recently, just like right now. So in other words, sort algorithm inside the arrays class is only designed to work with primitive data types, but I can make a twist. I can make a change that will simply allow me to use the sort algorithm that comes in the arrays class. And this is something that we're going to talk about in the week before the final. Now, just like how we talked about inheritance last class, there's something called abstract, there's something called interface, and there's something called polymorphism. Those three concepts are related to object-oriented programming, and we probably will going to talk about them very, very broadly next class. But for now, I'm just going to show you that we can use something called interface that will allow us to use the sort algorithm. Now, with interface, this is simply how do we use interface. Interface, it's like a class that forces you to get something done. And interfaces, again, from the name, it's simply going to allow you to interact with other classes based on whatever you choose. Usually interface comes with methods that has no body, no implementation, just the header, and you have to implement the interface inside your class, override it. And also sometimes interfaces can inherit from other classes. So the interface is simply going to act like something in the middle between your class and another class to get something done. So We do have another class that is part of the interface that we don't have to worry about it. And we're going to use the interface that I'm going to show you right now to make it possible to use the sort algorithm. So the idea goes like that. Last class, we said whenever you want to inherit, you type extends. Now you type implements whenever you want to interface. And then you type the interface class that you're trying to use, comparable. And then you specify the class that you want to actually utilize for the comparable. So you're going to use the same book class. Now, immediately after you did this, he's telling you have a problem. Whenever you interface with another class, you have to override the method. And since I didn't override it immediately, he told me that, oh, you have a problem here. And you need to actually, add an unimplemented method. So this is something we have to add, of course, to our class. So what is the name of that override that we have to do? I'm going to go and put it all the way to the bottom. Let me see if he's going to automatically create it for me, but he should. Come on. Show me that message again. Did he add it? And here it is. Yep, that's exactly what I was going to write. So we have a method called compare to, and the compare to as a method, it's part of the comparable interface. And the compare simply take an object O, which is the one where we're trying to use it for the sorting algorithm. It's a public, it's return an integer. And in this case, by default, it's just going to say return 0. But here's what we need to return. We need to return the following integer. Now, here's the thing. Since I use what?
What did the top say? Public class book implements what?
Comparable implements comparable book.
And then where does book come from?
Book is the same class.
The comparable book.
Oh, this is something already been created. It's part of the Java programming. It's in the library.
Oh, okay.
I'll say you see how I did here, importing the Java and util array. So this comparable interface, it's already somewhere in the project. Like if you go to the library here, it's defined there.
Yeah.
Now, the reason again, this is something very, very advanced. Do you see this part here that I'm having the book? Okay. Isn't that remind you of the array list? You remember when we created the array list, how we used to use those greater than, less than? This is something we use in Java. It's called generic programming, where you can associate the class with any data type. And this is the data type that we're using for this comparable class. It's called generic programming, and this is something advanced you're going to learn in your next programming class. But I'm just showing you, in general, if you want to sort any array of objects, this is the line that you have to add to your class. And then after that, inside the body, since we are using integers, number of pages here, to use as a comparable item, so we type integer dot compare, and then after that you open a parentheses and you close them. In the parentheses, you tell me what are you doing, what are you using here. So we're going to compare this dot number of pages with a lowercase a, comma O dot number of pages. Number of pages. What is he complaining about here? Okay, get number of pages. I should be able to have access to it. I'm still inside, but he doesn't like it. Okay, well, I'll just go ahead and do it. Get number of pages. Anyway, so here's the deal. If I just want to summarize this this technique that I'm showing you here. I'm telling him, when you want to do the sorting algorithm using the books, I want you to compare the number of pages of one object, one item in the array, with the other item in the array, the number of pages. So you need to sort the data using the number of pages. That's simply what's going on here. Okay, go ahead.
Yeah, so my question is, so the whole goal of using the abstract here is to be able to sort all the different elements of the array based on a specific criteria?
Yes.
Okay.
That's the whole point, by the way. This is how you sort objects. You have to choose one property to sort them based on. And in this case, I decided to go with number of pages. Let's see if this is going to fix the problem. If we go back to the main page, run it, and look at it now. 23, 55, 129. Okay, so let me just go back to the book. Number one, if you want to actually, again, utilize.
We go back to the main. Yeah, I just need to copy something real quick.
Go ahead. I'm going to post this, by the way.
Okay, thank you.
Okay. So if you want to use sort arrays.sort with non-primitive data types, you need to go to the class of that non-primitive data type, and you need first to implement the interface comparable using the same object, same class name. And then at the bottom, you have to override this compare to method. And in this compare to method, you're going to return integer compare, and you're comparing simply the number of pages of one object with the number of pages of another object. So you're comparing the pages of one book with another book, and you utilize that. Can we use with the string? Well, that's a good question. We can try. Let me see. The problem with the strings, I'm not 100% sure about how the compare is going to react to the strings, but I can totally give that a try. The idea here is that instead of, you should return integers as well. Let me see here. If I say use title, and let's say use get title, and he didn't like it. I kind of knew it that he's not going to like it. Here it is. Because the compare method use integers, type integers to be applied. So maybe if I change this to a string, no, he doesn't like it. The method compare. What is that?
And just use the ASCII table, the character, and for the comparison.
I'm not sure, but I like when you asked that question, I was like, yes, I should be able to use the strings, but the strings are non-primitive data types themselves. So that simply means there should be another way to get that job. I need to go and dig and see how is that possible. But this one would not take it, because even if you change those two strings, the return of this. Oh, wait a minute. I think I might actually. Wait a minute here. If I go title, I forgot something here. Get title, and it should return a string. And let's see if I can put a string here, and let's see if it's going to take it. Now the compare doesn't support. If I put it here, oh yeah, of course. Here's the thing: you're overriding this method, and the method actually has the integer as or the data type that's returned, so you cannot change it. I need to go and dig and see how can I actually use strings instead of integers. Integer compare, and again here this method compare integer type integer doesn't apply for strings. So there's another way to do the strings. Number of pages.
So Can you compare characters? Because that's primitive, right?
If you want to use, let's see here, probably you need to go and you need to have a look at the compare method itself and compare to method itself and see how is it defined inside the comparable class. So that simply means you need to go and dig inside the class itself to see how is it going to actually deal with other data types. I believe in a case like that, looking at the documentation of the interface should resolve a lot of this issues that we're having right now. I'll try to have a look at it. I'll put this in my mind and see if I want to use other data types, how would that work? So let me just put that as a note here. How about strings, characters, doubles? Okay, so we'll put that in as a comment. And that's going to be a good thing, actually, to go and do a research about it. And by the way, let me just tell you something that I'm glad that I was asked that question. And this is actually how you learn. Like as you go through something, okay, I know how to do the integer right now, but you have to ask yourself, okay, so how do I deal with other data types? That simply will take you to go and reading about other items and learning about them. I knew that we should be able to use other data types, but the name of the methods and the syntax for those methods is not in my head right now. So I just have to go and do a little bit of research to figure out how do we deal with other data types. So this is one way to get the job done. And what I'm going to do, instead of using array.sort, how about if I do it myself? And to do that, I'm going to come here at the top and say public void sort books. And then we are going to simply pass an array of books. We'll call it books. And maybe to make it easier, we'll pass also, well, I don't need to pass anything. We'll just keep it that way. So here's what I'm going to do. I'm going to simply create my own method to sort the books. So I'm going to come here, instead of array.sort, I'm going to say sort books and we'll pass my books. And remember here, we said whenever you pass a reference, let's see, why is he complaining about this? Change to static. Oh yeah, forgot. Public static. Right here, static. Okay. This is me creating the sorting algorithm itself. Now, there are many different ways we can sort values. And the PowerPoint in the array chapter described a sorting algorithms called selection sort. And today we're going to go through the sort algorithm itself and try to explain to you how does it work. I think I did explain it, but let me just go and try to remember the sorting algorithm that I'm going to use. And let me just control N this. No, control N. Works as following. And I'm going to make it very simple. Imagine you have those four values, 2, 4, 1, 3. And I want to sort those from the smallest value to the greatest value. Now, as I said, there are many, many different ways of sort. Oh, wait a minute. I have to share my screen before I continue. So here we go. I do have those 4 values, and I want to sort them from the smallest value to the greatest value. What I'm going to do, I'm simply going to assume that 2 is the smallest value, and I'm going to compare it with the rest of the values. And then every time I found a value that is smaller than 2, I update the smallest value. So at the beginning, I will assume that mini equals the first value, which is 2, and the index of that value is 0. Now, as I'm scanning the array from 4 all the way to 3, 4 is not smaller than 2, but 1 is smaller than 2. So what's going to happen? Mini is going to be changed to be 1, and the index is going to be 0, 1, 2. And then after that, I continue, and 3 not is smaller than 1, so we're going to stick with the mini value is 1, and its index is 2. So since the mini value, the original value, changed from 2 to 1, that simply means all I have to do is swap this value with this value. So I'm going to end up having 1, 4, 2, 3. Right after that, we go and move on to the next item, which is 4. I'm going to assume that mini equal 4, and the index of that is 1. After that, I compare, since 2 is smaller than 4, so now the mini is going to equal 2 at index 0, 1, 2 at index 2. And then after that, since 3 is not smaller than 2, so nothing's going to happen. At that point, we're going to swap 1 with 4. So I'm going to end up having 1, 2, 4, and 3. And then after that, we move to the third value, which is 4 again. So mini equal 4, and index of that 4 is 0, 1, 2. And then we compare with the last value, which is 3. Since 3 is smaller, then we just simply perform a swap. And then you end up having 1, 2, 3, 4. So this is the algorithm that I'm going to try to apply it to the books. So the idea here is very simple. Let me stop sharing. Let's go ahead and try to implement that method. It's going to be a long one. Let me just tell you from now. And it's up to you to choose whatever you want. You want to go with using the inherent interface, go for it. And this is something actually I'm going to talk about here a little bit. In interviews for jobs, they usually ask questions about, here's a problem, need to solve it. Sometimes you don't remember a name of a method, okay? Or you don't remember a technique to get something done. Like, for example, using the array.sorts and inherent and implements that interface, compare. So instead, you just go ahead and create it from scratch by yourself. I personally think being able to do that is showing that you know the programming language very, very well. But some companies, they don't really like that. They say, well, there is an existing library that you don't know about its existence. So if every time we're going to ask you to get something done, you're going to have to do it yourself, it's going to take you forever to get the job done. But again, that's not the case, because usually when you work, you have access to everything. So it's not like you're doing an exam or an interview where they just cut everything from you. You just have a piece of paper and pencil, and they ask you to write the code. Some companies, believe me, do that. Anyway, so let's go back here. I'll try to get this done as fast as possible. What do I need? I need to have a for loop. Number one, integer size equal books dot length, because we need to know how many books do we have. Why are you complaining here? Length. Oh yeah, I've been doing the parentheses, my bad. Now we go there. For integer I equals 0, I is less than size minus 1. Okay, now you may ask why minus 1. I'll explain that in a sec. And open parentheses and close it. Now, why size minus 1? Because if you go back to here, by the time you get to the last item, there's nothing after that. So the last time you're gonna process and perform any action is when you get to the one to the before the last item. So when we get to 3, we compare. Sorry, when we get to 4 here, we compare 4 to 3, and that was it. By the time you finish the swapping and you get to 4, there's nothing to do after that. And for that reason, where is it? Where is it? For that reason, you don't need to go all the way to size. So it's going to go size minus 1. Now, here's what I'm going to do. I'm going to come here and say integer mini. Oops. Integer mini equal books of I dot get number of pages. So this is the first thing. I'm getting the mini, and I'm getting the number of pages of that mini. And I'm going to come here and say integer index, and that index simply equal I at that point. And what do we do here? We go for, and look at this, very, very important, integer j equal I plus 1, as long as j is less than size, j plus, where is it, plus plus. Now you may ask the question, what is the point of this for loop? And allow me to go back to this. I said at the beginning, you're going to start with this assumption, and then you're going to scan the array. So the part of me scanning those 3 items, this is where j is utilized. I is utilized when I check this value, and then I check this value, and then I check this value. That's where I is utilized. But for every time you use I, j is going to equal whatever I is plus 1. So you start from this item all the way to the end. You start from this item all the way to the end. You start from this item all the way to the end. So this is where those 2 nested loops are coming from. One of them to scan the items 1 by 1. And the other one, for each item you're going to choose, you're going to scan the rest of the items, and you compare them with the item that you are currently at to look for the smallest value. So let's go back here. Let's say that's what we're doing. All I have to do at this point is the following. If, and this is going to be a little bit long expression. I'm going to say if mini was greater than books of j dot get number of pages. So I'm going to compare the mini that I assumed here, it's the smallest, with the number of pages of all the other books in the array. If that's the case, like mini was greater, that simply means I found something that's smaller. Mini is going to be changed to equal whatever that value was. And at the same time, index is simply going to equal j at that point. So I'm going to continue with this process for this for loop, with this if statement, until I am done. Now, here's the thing. There is 2 possibilities. Possibility number 1, that my assumption that the book that I am at right now is the smallest. And as I'm scanning the rest of the books, I didn't find anything smaller than that. So mini didn't change and index didn't change. So if that's the case, then my book is in the right place. Or actually, I found a smaller value. So I'm interested in whenever you find a smaller value. Whenever you find a smaller value. So what do I do whenever I find a smaller? And how do I know I found a value that is smaller than that? All I have to do is to come here and say if index doesn't equal I. Remember here, I is the current value that I'm looking for, and I assume that index equal I at the beginning. Now, if I found a value, number of pages less than mini, then index is simply going to be updated, and it's not going to be I anymore. It's going to be a new value for j. So if we find that index actually doesn't equal I anymore, that simply means one of the books had a value that is smaller than my original one. And this is where I have to swap those two books, one at index I with one at index J. So here's what I'm going to do. I'm going to say, and this is very, very important, book. So we're creating a new book. We're going to call it temp book. This temp book is simply going to equal book of, for example, I. So let's see here. Why is he complaining about this? Create a constant book. Oh, wait a minute. I called it books. My bad. Okay. So books of I. I have books of I now stored somewhere safe. I can come here and say books of I equal books of J. And then after that, what is he complaining about J? Oh, sorry, not J, index. Because index here is the value that we hold. And then after that, books of J equal temp book. And again, index. Now, if this part is not clear, how am I doing this swapping operation? Let me just go ahead and explain it to you in the Word document again. And let me use this space here. Imagine you have those two values. You have 5 and you have 7. And you want to swap them. Let's say this is x1 and this is x2. You want x1 to equal 7 and you want x2 to equal 5. To do that, this is what you have to do. You're going to come here and say x3 equal, let's say, x1. So at this point, x3 simply is going to equal 5 because we assigned x1 to x3, so x3 equal 5. If you come here and say x1 equal x2, at this time, x1 is going to equal 7. So I'm ending up having 7 here and 7 here. And then after that, when you say x2 equal x3, x3 hold the value of 5, so x2 is going to equal 5, and that simply means this is going to equal 5 after that. So this is how we do the swapping. Let's go back to the book, and that should perform the swapping operation. Now, this is, again, the moment of truth. Let's see if this is going to work. I need to get exactly the same output here. I have not tried this. This is the first time I'm trying it, so let's see if we're going to be able to get it done. And actually, it worked. So this is, again, how we perform. Now, this is not the fastest way to get your data sorted, but this is just to show you that, in general, this is one of the simplest way to sort the books. The idea here is, again, you have nested loops. You take each item, again, if this was a primitive data types, it's going to be a lot easier. But since it's not primitive data types, I had to go and get the number of pages every time I want to access to them. And then once I figured out where is the smallest value, I'm just going to swap it with the one that I am currently at. And then it's simply going to go and swap it. Now, the question that we have is simply asking you to perform this sorting algorithms on those two classes, the houses and the skyscrapers. And I will provide you with both of those files. And it's up to you to choose whatever you feel comfortable with. I would say, for your own sake and benefit, use one of them. Use the interface for one of them and use the create your own method for the other one, just to, practice. So let me stop sharing. And as I said, I'm going to upload this file once we're done with the class, and I'm going to upload the video as well. So this is everything that I wanted to talk about. I'm going to make sure that I will go and double check on how do we use the compare interface to with strings and characters and other primitive and non-primitive data types. But usually, again, if it's not primitive data type, then you're asking for like a lot of troubles, because the whole point of using this interface is for you to be able to use a primitive data type within your class to sort the data. And now you're saying using a string, and a string is not a primitive data type. So it's like a dream inside a dream. So that's where the confusing is coming from. Anyway, so this is everything that I wanted to talk about today. This is again a reminder that on Tuesday, you simply utilize that time to answer project number 8. I'm not going to be able to be here. And if you have any questions during the Thanksgiving break, again, use Canvas page to send me any messages. Are there any questions?
Yes,
Go
I
ahead.
had issue getting the previous file for the last class. I don't know if I'm the only one or other people had the same issue.
Can you repeat that again? I couldn't hear.
I had issue getting the file for the last class, the one that you use as a
Oh, wait a
demo.
minute. Let me share my screen then. If I close it, let me go to modules. And if you go to those mini projects, you should be able to see them. So what did we work on last class? We worked on
Inheritance.
here, those classes. So if you click on any of them, it should be shown here. You don't see it at your end?
I was having issue to download, and I'm going to-
Download? Let me see if I can download it. And here it is. If I open it, you can't see it, but I can share it right now. Where is it? Desktop. I don't know if you can see it or not.
I can see it. I will try it on the other laptop and see.
Yeah,
Thank you.
there should not be a problem there. Any other questions? Okay, so let me stop sharing.